So we can start, okay? So thank you to Anfao for the availability for presenting the Microalgae project. This is our the title of our presentation. So behind the lens, microplastic in eyewear, the environmental impacts of microplastics and practical approaches for managing them. I'm Marco Calvi of Certotica, and I'm here together with the colleagues of the OCO Institute, Michelangelo Lamonaca and Anna Meyer, that helped me to present the first result of the project. So regarding the agenda of this seminar, this is the list of the main points. So what are microplastics? So the impacts of the microplastic on the environment and also on the health. The EU regulation on microplastics that could be interesting for the companies. The project Microalgae with the objectives of the Interact projects. So then the other point is waste from lens manufacturing, so the experimentation that we are performing within this project. Then the centralized lens production and plastics waste in the eyewear industries, and finally the solution state of the art. So I leave the floor to Michelangelo. Thank you.
Thank you. Thank you, Marco. Yes, let's go on with the topic, with the chapter of what are microplastics. We are going to have a couple of slides regarding this topic because it's a pretty new topic and also pretty vast. So when we talk about plastics, we know that plastics is everywhere and in our everyday life. We wear plastic and we have to do with plastics every day. We also sit on chairs out of plastic. But when we talk about the sizes, the range of sizes of plastic, we have to go deeper, and we have three main categorizations according to the size, which they are according to the diameter of the particles of plastic. So we have, in case of a diameter which is major of 5 millimeters, we have large plastics or microplastics. Then we have the microplastics, so objects, particles of plastics which have a diameter in a range of 1 nanometer and 5 millimeters. And what stands below, what falls in the category of particles less than 1 nanometer, then are nanoplastics. And to have a comparison with the reality, when we talk about microplastics, we are talking about some very small particles that in real life are comparable, for example, to the size of blood cells, or for instance to a strand of DNA. So it's something that we cannot see. We need a microscope, or they could also be filaments, like a piece of hair, but most of them are very, very small, and we cannot see them with our eyes. The most important question that we have to ask ourselves is how they are created, where are they coming from? There's always a source, because plastic is made by man, processed by man, and how it is done, how it is created is either in a primary way or in a secondary way. In the primary microplastics refer to all those microplastics or those small particles which are contained, for instance, in cosmetics products and are on purpose put into those products. And secondary microplastics are those small particles that are created from large plastic products, like plastic bags from the supermarkets, or tire wear from the tires of cars or tractors and whatsoever. And how they are created, the secondary, through the degradation, and approximately 70% of this plastic waste lands in the oceans. And over time, plastics get fragmented into progressively smaller particles. Why is the topic of microplastic crucial? Because yearly we produce globally 400 million tons of plastic waste. Of all these 400 million tons, only the 9% are recycled, the 12% are incinerated, and there's a big amount, so the 79%, which is standing in nature, is going to be accumulated, and nobody knows what happens, but nature actually knows what happens. Plastic is not a dead material, it's actually living, so to say. So it degrades through atmospheric agents like wind or the light of the sun, but also through man actions like incineration or shredding of these these microplastics in more smaller particles, and that's why they also become very dangerous, not only for the environment but also for the human health. And we explain here the impacts that they could have on the environment, because when they are exposed to the light or to the waves of the sea, when they are landing in the oceans or on the landfills, they absorb toxins and they become dangerous indeed. For instance, what can happen, one of the impacts is the contamination of diverse ecosystems from the remote alpine areas to the deepest side of the ocean. Why? Because, as we said at the beginning, plastics is everywhere and in our everyday life. Then it also started creating new ecosystem, new geological materials, such as plastitone or plastic agglomerate. And then animals see them as a house for their because they are becoming new ecosystems for them, and they are proliferating new animals, but they are also eating those small particles, which can bring them to starvation, to death, because their digestion system cannot handle this weird material, this strange material. And also they contain plasticizers, which are often altering the hormonal system of the male species of some animals, which cannot then help or reduces the perpetuation of the species. And on a human health, on people health, which are the impacts? So things like inflammation, because they can penetrate our tissues, or toxicity. Some of them could be toxic, or they could bring to the damage of some cells in our body. All of these impacts regarding the human health are must be investigated, but still we have some evidence that they could enter also our body, and they could have some impact. But we don't know yet how much they could be negative or positive. We don't know that. And regarding how we could go on according to this first infos about microplastics, we can see now what the EU regulation is doing, and I give again the word to Marco.
Okay. Thank you, Michelangelo. And yeah, regarding the EU regulation 2023-2055 on microplastics, I give you some pills about this regulation that was adopted in 2023, and this could be interesting maybe for the companies and also for our sector, so the eyewear. Briefly, the aims of this regulation is to restrict, so the restriction of the synthetic polymer microplastics, in general microparticles, on their own or intentionally added to a mixture or to a material. So we can talk about, for instance, about glitters or other kind of detail that we put on the objects, on the products. Regarding the regulation says that microplastics, microparticles of this added on this regulation is under the 5 millimeter of diameter, as told before by Michelangelo. So this could, as I told before, include the different sector, industrial sector, and different product, but there are some exclusion regarding the products, including glitter, for instance, made of material that are not synthetic, okay, that is inorganic, natural or biodegradable, or soluble in water. So beads and sanguines, and this is a sort of a list that the regulation show for the exclusion. For instance, also products that are under the REACH regulation are excluded, or products that already went on the market before October 2023, so before the adoption of the regulation. The regulation talk about also the different periods, transitional periods, based on the sector of the products. For instance, from 2027, the regulation will be applied for rinse of cosmetics, from 2029 for leave on cosmetics. From 2029, we will also add the device falling with the regulation of medical device that could include our sector. In any case, we talk about the regulation 2017-745, and from the 2035, also the makeup, lips, and nail cosmetic will be included. So these are the main point of the regulation. Another interesting part of the regulation regards the manufacturer of the polymers. So industrial manufacturer, so who produce the synthetic polymers in the form of pellets, flakes, or powders. Okay, for instance, who produce the cellulose acetate, the nylons, and so on. And starting from 2027, also the user of these pellets, of these synthetic polymers, will be go under this European regulation. So this is the project, MicroAlps, that we're talking about, that is financed by the Interreg program. So we are talking about an European project. These are the partners, so Certotica, the lead partner, Ca' Foscari University of Venice, the University of Carinthia, in particular the Admire Research Center that is specialized for the 3D printing, and the OCO Institute that my colleague represents here. This is the total budget of the project and the co-financed part. And the project, as I told before, is the Interreg Italy-Austria project. Anna?
Thank you. And as we heard already, especially industrial production processes as well as private use create microplastics, which might eventually go also into the environment. So our goal of this project was to tackle this problem, the problem of microplastics in the environment, and also what to do with them. By especially raising awareness, because this is the first step to get some change. And we focused especially on the Alpine region, because this is a very sensitive ecosystems, the Alps, the mountains, not only in the Alps, but especially mountain regions. So this was our first scope. And also we focused on the optical lens industry, since it should act as an example industry as well as pioneer, because we want to have these outcomes also to be transferred to other sectors possibly. So what we did also, we focused on the detailed production processes, especially lens grinding, and tried to find solutions for collection and the recovery of microplastics, and followed by the testing of the recyclability of these plastics, and also maybe for possible use as in, for example, a 3D printer, or what else could be possible with it. So this should also act in our overarching goal to transfer this knowledge to also other sectors, so that the microplastic problem should get solved on a large scale, national, global, whatever is possible. So the project is kind of a pioneer pilot project to also be transferred into other sectors.
Yeah, in fact, yeah, one important thing is that the eyewear is not the first source of microplastic, but the first source could be, I don't know, the car wheels or the textile. This is only, let's say, a case study that we are using for understanding how to recover the waste coming from the lens grinding, in this case, and how to produce something innovative with the 3D printing, as told by Anna. So by the Microplastics project, we investigated two of the main material that are used for the ophthalmic lenses, so the CR39 and the MR8 or similar materials that are the main material used for the production of ophthalmic lenses. CR39 is more or less represent more or less the 50% of the market on our study. Let's say in this case, CR39 is polyallyl diglycol carbonate. That is one of the most famous polymer used for the lenses, and then MR8 that represent more or less the 20% of the market. So we investigated and we done experiment with these two material. This is our lab in Certotica. We reproduce the lab of an opticians or a lab cutting laboratory, and we have here a grinding machine for the grinding of the lenses, obviously, and here we reproduce the waste that we usually find in an optician shop or in a labs. So we perform some tests with at this stage with the CR39, and we collect the waste with this kind of filter that you find on the right. We characterize also the waste, chemically characterize the waste in order to understand the physical and chemical composition of the waste. In Europe, in Italy, but maybe in Europe, this is the code that we assign to this kind of waste. So this CR code, the European code of the waste, so 150203. Then we dried the sample, the waste coming from the filtering system. We dried the sample, we obtain a sort of powder that we used, thanks to the collaboration of Ca' Foscari University, as filler material for the 3D printing blends. So now we are studying how to use the waste into a blend. We are doing experiment with the PE, so the polyethylene, and the PLA, polylactic acid, in order to understand what's the best recycle, what's the best way to reuse the waste. So in this case, we perform, and we are performing tests with a mixture of 1, 3, 5, and 10% of the waste into the respect to the polymer. These are some pictures that show you what we are doing. So we are trying to produce the extruded filament thanks to an extruder, and these are the first attempts that we perform. So we have the extrusion phase, then we have the pelletization, okay, and then thanks to the admired research from Villach, Austria, we use another kind of extruder in order to produce the final filaments that was fine for the 3D printing. On the right, we can see some trials for the production of the filament with the CR39 with a percentage of 10% of the waste on the matrices. And this is some trials that we perform at different temperature. With this filament, we would like to to create new objects for the optician or for the labs in order to close the loop and try to give more value to a waste that currently goes in the landfill or at maximum to the incinerators. So, Anna, I give you the floor.
Thank you. And while one part of the project was to find out how to recover and recycle the microplastic produced in this sector, the other one was to investigate how is the actual market situation in reality. So where do we get the microplastic from if we have found a solution to recycle it? And second, how high is the decentralization? So is it a matter of just a few big industries, or is it a matter of a lot small opticians, which makes it way more difficult from a point of management view and also from a financial point of view and education as well? So to find out this, we conducted a survey, which we sent to the main actors, which are the optical stores and the optical lens production sites. And as I told you, especially in the Eastern Alpine region, since we focused on this area, and the aim was to find out, do they even apply grinding and milling processes? Do they use water? And what happens with the water? And what happens with the microplastics? And do they filter the water? So these were the questions they were asked. And the main aim of the survey was not to get a detailed overview of how it is, but more to get a big picture of the situation so we know where to start and how or where to build on if we have found something for recycling, for example. So the main outcome of this survey was that actually there is a certain degree of decentralization. So opticians, also small optical stores, do grinding and milling processes. And there are also some of these stores who do not sustainably manage the water or the microplastics. So this tells us, okay, there is a potential for improvement. First, to get all the microplastics out of the water so it does not even get into the water cycle. And second, also, it means that there is decentralization. So in terms of legal regulations or also from a management point of view to collect all the microplastic, you have to consider that there are many small opticians who can take part of this whole process, which makes it also kind of more complex for a managing point of view. And more details of the survey. So actually 70% of all the respondents apply grinding, so they also produce microplastics. And almost all of them, so 94%, use water for these processes. Actually, almost 1/3 of them do not filter this water, so the microplastic gets into the water cycle without any filtration process or any separation, and the rest of it does filter the water. What happens with the water? Almost 20%, let's say, recycle the water. So this is also important from a climate change point of view, because the water stress, as we know, gets just more intense. So we are interested in using less water. So this could be an important point for that topic. Nevertheless, coming back to the microplastics, 75% dispose the plastic waste properly, which does not mean they recycle it, but they only put it in the foreseen boxes, because it is not recyclable because it's a big mixture of many different polymers. So by now it's only disposed, and 18% dispose it in the residual waste. So the one everybody of us has at home too. And yeah, the rest did not answer this question. So what do we know from this? That, as I told you, there is more potential to use filtration machines for especially small opticians. And also there is a degree of decentralization which has to be considered in this topic, also collecting microplastic, recycle it. And we also wanted to widen the focus a little bit also on other plastic sorts, because it's not only about microplastic, but it's also about resource use and how to decrease the use of resources, decrease the amount of waste in general. So we asked, what are other types of plastic you're using and what is other type of waste? And actually there is a lot of different types. There are the lenses, the defective one, the demo lenses, the support disc. There are a lot of different films and foils. For example, the stick-on lens films, grinding foils, protection foils, and also auxiliary material for production processes like the different sorts of pads, bonding agents, and so on. If you're from the sector, you know what I mean. So, and also frames, filters. So there is a lot of different material, and maybe with this more, or with these bigger parts, it's also easier to reduce or to avoid plastic here, because it's not about something complex and mixed like polymers, but it's maybe a problem which is more easier to tackle. So this could be a starting point for another project or another time, but we investigated, actually we are interested in the microplastics. So what you are maybe interested the most in, what are actually the solutions? So how can we tackle the problem? And first of all, we think it's essential to raise the awareness, because you only do what you know. So it's important to educate consumers as well as producers. And from a technological and management point of view, it's first, maybe it could help, it's our suggestion, to separate the different types of polymers as good as they can, or as it is possible, because the less polymers you have, the easier it is to recycle. So it could be a possibility to maybe separate the different types of lenses. For the smaller opticians, it might be a technical solutions with the machines. For the bigger one, maybe in the morning you use these lenses, in the midday this. So it's at the moment it's kind of a dreaming, but we are finding out whether it's possible. And this, but is also only possible if there is more advanced technology or more research done, because it's only rentable to separate if there is also the technology who can use it. So this is the next point, and the very first point is to even get the microplastic, you need to filter it. So currently there are no legal regulations to actually filter the water from microplastic. Maybe this could help, but if there is a regulation, or also if we want the also smaller opticians to filter, they need maybe some financial support to have these machines and the technology. What can be done with this microplastic? Maybe printed with a 3D printer, maybe also other uses. We are investigating the 3D printer and looking what's possibly there, but maybe the most effective short-term measure is to raise consumer awareness about buying high-quality glasses, which are long-living, and so that less lenses need to be grinded. And this is also my take-home message for you. We hope you enjoyed the small presentation, and thank you for your attention. And if you're interested, we also have a very short survey for you about consumer awareness and also ideas you have for the optical sector. So feel free to fill this out, and feel also free to reach out to us in case you have questions. Thank you.
Any question? Domande? Grazie. Thank you very much.